The first graph that we'll take a look at doing by hand in 4.5 day 2 is the tangent graph. Now I am going to assume a few things from yesterday's lesson, some basic knowledge things that you take away from yesterday's lesson. One of those things being the fact that we know what cosine looks like. So when I'm doing cosine, one thing about it is I know that it's going to start at 1 and it's going to hit at 0 right here, and it's going to come back around, hit at 0 right there, and continue up to 2 pi. So one thing that we know about cosine is that it will be 0 at pi over 2 and at 3 pi over 2. It'll also be 0 at negative pi over 2 and negative 3 pi over 2. So just keep in mind that that is one thing about it. Now, we talked in the last video about how tangent is undefined when cosine is equal to 0, and that's why I even commented about those, was because I wanted you to know where cosine is equal to 0, and where in each of those spots we're going to draw a vertical asymptote, because tangent will be undefined at those asymptotes. Now the tangent and cotangent graphs are going to look similar to each other, but they are overall very different from the graphs that we saw with cosecant and secant. So here's what we're going to be looking at. Once we get these things placed, we're just going to pick a few points that that will help describe this tangent graph. And so in between these two vertical asymptotes, I'm going to pick a few points and pick 3 points and just see what happens there. So let's start by picking x equals 0. If I plug in 0 for sine or cosine, well, sine of tangent is actually the same thing as sine divided by cosine, as I mentioned already. So sine of 0 is equal to 0, and cosine of 0 is equal to 1. So what this is really saying here, if I do tangent of sine over cosine, that's just really saying 0 over 1 at x equals 0. So what that means is there's going to be a point smack dab in the middle of those two lines. Now the other thing that I think would be a good idea to do is to find another point that's right in between these two marks. Now this is 0, this is pi over 2, and so that's going to mean that this will be pi over 4. Now maybe you remember from yesterday seeing pi over 4 in certain places. So pi over 4 is going to again come back and do something for us here, but let's take a look at tangent of pi over 4. Let's plug that in as a side problem here. Tangent of pi over 4. Now we do again have to go back to our special right triangle in this case. So if I have tangent of pi over 4, that is going to look like this. So we've got square root of 2 for both of the legs. Oops, there we go. You can see that a little better. Square root of 2 for both the legs, and then 1 for the hypotenuse. So tangent is opposite over adjacent, meaning that we'll have square root of 2 over 2 divided by square root of 2 over 2. So that is equal to 1. So that's a nice, neat number. It's just 1. So when we go up on this graph, we're going to say, all right, go up 1, we're going to go down 1. Here is positive 1. Okay, so that's a point that we have here. Another point that we're going to have is, let's go to the other side, let's do negative pi over 4. And we're going to see how that one functions in this case. So we could plug in y equals tangent of negative pi over 4 and see what we get for that one. Now negative pi over 4 is pretty much the same, it's almost the same thing, just in the fourth quadrant instead. So I'm going to go down here and just kind of add this on to that picture. So if I draw another 45 triangle here, that just means that this side's still square root of 2 over 2. This side is negative square root of 2 over 2. And so if I do opposite over adjacent, that's going to be negative square root of 2 over 2 divided by square root of 2 over 2, which is negative 1. All right, so now I've got another point that I can put in this graph. It's going to be at negative 1. There's that point right there. And so now, if you saw the graphs at the beginning, what these kind of look like, the tangent and cotangent graphs, it looks a little something like this, where they have this curve to them like that. And so we're going to, just using that shape, make a sketch that goes through here, and it's going to go up that direction. This one's going to go down this direction, and we've got one of our branches of this graph. Now you'll notice that it goes up forever here and it goes down forever there, so it's not going to connect to these next ones. And the good thing about tangent graphs is that once you've got one branch, you've got them all. They just repeat themselves, and so I could go here and just symmetrically do the same shape. They're all going to go the same direction. They're going to have the same numbers for the points, and I'll get just a few extra pieces so that we can have a full picture of this. Now, like yesterday, I'm looking for at least 2 full periods. This one actually has 3 full periods to it, because a period is when the graph goes all the way through and then starts repeating itself. So this one has 3 full periods. You wouldn't have to have that many, but it's fine if you do. Now, one other thing that I want to mention about this is, since we're talking about periods, what is the period in this case? Well, it repeats from here to here. Now this point, if you remember, this was pi over 2 at that spot. This was negative pi over 2. The key thing between this is the distance. If you go all the way from here to here, this is going to be a total change of pi. So what that means for tangent is that if we don't do any transformations to this thing, the period is going to be pi. That's different from every other graph that we've had so far. So that's something to really make note of here, is that the tangent is pi. That's also going to be the same thing with the cotangent, but we'll get to that in the next example. And like the last ones, what I want you to do, one last piece, is to label that first point that we found, and that is pi over 4, 1. That'll tell me you found that one by hand. We have the picture down here with our right triangles, and so there is a lot of stuff that goes into this, but once we get the idea, we're going to see how this is, the pattern keeps going with a lot of other things that I do. So that's the tangent graph. Next up, you will see a very similar process for the cotangent graph.